Guys, for those of you who missed this activity we did in class, what we were trying to do is figure out the sum of the interior angles of a regular pentagon. So regular means all sides and all angles congruent. So here's what we ended up doing. We ended up looking at one vertex and connecting it to other vertices to break up this pentagon into a shape that we're more familiar with, which is a triangle. So this pentagon, with its 5 sides, had 1, 2, 3 triangles within it. And each triangle is made up of 180 degrees. So if we multiply the number of triangles by 180 degrees, we get the total sum of the interior angles of this pentagon, which is 540. 3 times 180. And then if I wanted to know the measure of each, because it's a regular pentagon and all the angles are congruent, I have 5 congruent angles in here. So I just need to divide this 540 by 5. And I get 108. Okay? Looking at the other side, we did the same exercise with an octagon. So using that same logic, our octagon has 8 sides. And I pick a corner and I break up this octagon into some triangles. And I get 1, 2, 3, 4, 5, 6 triangles. And each one of them is 180 degrees. So I gotta multiply the 6 triangles by 180 degrees to get 1080 is the total sum of the interior angles for this octagon. And again, if I take that total 1080 and I divide it, because it's regular, by 8 congruent equal angles, I would get that the measure of each is 135 degrees. Okay, so using this pattern, I wanted to know, what could we say about an n-sided polygon? N number of sides, meaning I don't know the number of sides. I want a general sense. So my 5-sided shape had 3 triangles. My 8-sided shape had 6. So I'm going to say that my n-sided shape will have 2 less triangles than however many sides it has. So n minus 2, 2 fewer. 8 had 6, 5 had 3. And then I'm going to multiply that by 180. And that would be the sum of the measures, sum of the interior angles. And sorry, that's like a typo. Okay. And then if I wanted to know each for a regular polygon, I would take however much this came out to, and I would divide it by however many sides I have, n, which is what I did here.